Hello class, this is a combination of both lessons 7-4 and 7-5 in your textbook. One of them is about exponential growth functions and the other is about exponential decay functions. So we're going to mix them both together at the same time, but first let's just talk about what is an exponential function. Well, it's different from a linear function. If it's written, it's going to look like y is equal to some number times some other number to the x power, okay? Or in this case, a cannot be 0. Also, b must be greater than 0, but it cannot be equal to 1. And so many times, I'm just going to draw a little sketch right here. If you see an exponential function and it's graphed, it's not going to look like a line. It might look something like this, okay? Where it's running along one of the axes and then it's curving up and then it's just going to start going straight up forever exponentially. So let's go ahead and look at our first example. We're given a set of points, some data, and we're asked to write a rule for this function. Okay, and by a rule, I mean I want you to write what the function is. Okay, so it's going to look like an equation. So we only need to find two things. If it's in this form, we need to find the a and we need to find the b. So I would say that the a is probably the easiest to find in your set of data. The a is always right here. Okay, it's wherever the x value is, the y value is your a. So if the x value, I've got to specify that, when the x value is 0, then the y value, you're going to look for that. And if that's 8, then that means that your a is going to be 8. So you have no work. It's just kind of looking at the function. The part that's going to take a lot more work is looking at the pattern that you see. Now in the top, to get from -2 to -1, I'm adding 1. -1 to 0, I'm adding 1. 0 to 1, I'm adding 1. So it looks like the pattern on the top is adding 1. The tricky part is looking for the pattern on the bottom. Now, to get from 2 to 4, it looks like I'm adding 2, but then that doesn't work for 4 to 8, or 8 to 16, or 16 to 32. But it does look like I'm multiplying by 2 every time. And this right here is the hint that you are dealing with an exponential function if you're multiplying on the bottom instead of adding or subtracting. So, this number right here is actually going to tell us what our b is. So the b is going to be 2. So let's go ahead and just plug this in, and it's going to help us to write the rule for our function. Y is equal to a, which is 8, times b, which is 2, to the x power. And that's it. So this was the case because each of the y values were growing. This was an exponential growth function. I'm just going to put a note here. Okay. Let's go ahead and look at our next example. We're given another set of data. This time we're asked to write a rule again. So let's kind of do the same thought process that we did the last time. Again, we can find the a by looking where x is 0, and the y in that case is 1. So since y is 1, that's telling us that our a value is going to be 1. So that's pretty easy. Let's look at the patterns that we have for the x's. Again, it looks like every time I'm just adding 1, so that's not a problem. But the bottom, how do I get from 4 to 1, or 1 to 1/4, or 1/4 to 1/16? I'm not adding anything. It's getting smaller, but I'm not subtracting the same number. But I am multiplying each time by 1/4. If you have any problems like this and you get stuck, always look for if you can find a 1 and then see what you're multiplying that by. And that might be the easiest one for you to look for. So this is telling me that my b is going to be 1/4. So when I write this out, y is equal to the a, which is 1, times the b, which is 1/4 to the x power. It's very important that you have this in parentheses, because otherwise, if you had no parentheses, you would just be putting the 1 to the x power when it's the entire fraction 1/4. And I'm not going to actually keep the 1 in my final answer. I'm just going to write y is equal to 1/4 to the x power. And that's going to be my final answer. And since all the y values are getting smaller and smaller and smaller, it's actually kind of decaying. It's getting smaller. So we're going to call this an exponential decay function. And you're going to get a lot of practice in learning how to write these rules for functions later on in our classwork. So this next part now is we're given a function, y is equal to 2x, and it wants us to graph it, and then it wants us to identify the range and also the domain. Okay, so like we did in the past when we were graphing, we just get to choose points. So same with linear functions, you get to do the same thing with an exponential function. So I'm going to pick some easy values, -2, -1, 0, 1, and 2. And I'm going to plug them in and then get the y value. So when I plug in -2, this is really 2 to the -2 power. So you need to know what this means with a negative exponent. That means 1/2 squared, which is 1/4. Okay. Same when I plug in 2 to the -1, that's the same as 1/2 to the +1, which is just 1/2. If you plug in 2 to the 0 power, that's 1. If you plug in 2 to the 1 power, that's 2. And if you plug in 2 squared, that's 4. So let's go ahead now and let's plot these points. So let's see, I have -2 up 1/4. So barely is it going up. And then I have -1 up 1/2. Then I have 0 up 1. And then I have 1 up 2. And then I have 2 up 4. And as you can tell, these are not falling on a straight line. And so what you're going to do is you're just going to gently draw your line and curve it through all of those points, and then it should start to go straight upward for this case. Okay, there's some other times where you might draw it and it might curve downward, or you might have one down below that might curve upward to the x-axis. So there's lots of different variations, but I'm done graphing now. So now to identify the domain, I would say that the domain is any of those x values that I can choose, and it looks like I can choose any negatives or positive numbers. Okay, so the domain is going to be all real numbers. And now let's identify the range. The range means just the y values, and it doesn't look like they're ever getting below 0. They're always going above. So I'm going to say that it's all positive real numbers. And I'm done. Okay, so I have one more problem for us to do. This is another graphing problem. It's a new function, graph y equal to 1/2 to the x power. And then we're going to identify the domain and the range. So just like we did before, let's go ahead and pick whatever x and y values that we want to choose and plug them in. And I always like just sticking with the basics, -1 and 0 and 1 and 2 and -2 as well. And then I'm going to plug them in. So the first one is 1/2 to the -2 power. Okay, that's the same as 1/1/2 squared, which is 1/1/4. And the reciprocal of that is 4/1, which is just 4. Let's do the same thing with the -1. So 1/2 to the -1 exponent is the same as 1/1/2 to the +1. And the reciprocal of that is 2. Next one, 1/2 to the 0 exponent is just the number 1. 1/2 to the first power is 1/2. And 1/2 squared is 1/4. Okay, let's go ahead and plot these and see what we get. So we're starting with -2 all the way up to 4. And then I have -1 up to 2. I have 0 up to 1. I have 1 up to 1/2. And then I have 2 up to 1/4. And this time it looks like these are going downwards, starting from the left to the right, which is telling me that this one is a decay. So the top one was a growth, because as you were going along, it went bigger and bigger and bigger and it grew. So this was an exponential growth. While the bottom one is an exponential decay. Just going to add that to your notes. Okay, so let's go ahead and identify the domain and the range, and then we're going to be done. So the domain looks very similar to last time. It was all real numbers because I pick any negative or positive numbers for my x's. So it's all real numbers. And then my range looks like the same as the last problem as well. It's all positive real numbers. There's no numbers that are going below for the y value. So it's all positive real numbers. Then I'm done. So what I want you to do on your own is I want you to graph 3 different functions all on the same graph to try to kind of compare the difference between the 3 of them. So for each one, choose your set of points for the x's and plug them in, and then plot those points, connect the dots, and you should have 3 very different graphs on the same graph. And so come with that when you come back to class, and any questions that you might have, and I'll see you then.